Hello, in this video, let's look at a formula for the derivative of a function at a point. And there are two ways to do it. One way is to simply find the derivative of a function at any point x, and then replace that x with whatever point we're interested in, and then we will know the derivative at that given point. Alternatively, we can replace the x with the point right away, and then we have a formula for the derivative at that one given point. So the advantage of using the derivative at a point is, let's say I have a question right here below that says find the derivative when x is 2 if the function is 3x minus 1. I'm only interested at this one value, at 2. So if I use the formula for the derivative at a point, I will be done right away. Or maybe I have to find the derivative at when x is 2, when x is 5, when x is 6, when x is negative 3. Instead of doing the formula for the derivative 4 different times, I can simply do the derivative for all the x's and then have one answer and then in that one answer I would be able to plug in my values, the 2, the 3, the 5, the negative 6, whatever they happen to be. So that's the difference between the two formulas. The first one finds the derivative for any point, the second finds the derivative at one unique point. So let's use this formula, the second formula, to answer our question. So to find the derivative, we need to plug in the point A is, well, actually let's use this color. This is I apologize, that's not what I meant to. The A is 2. So in our formula for the derivative, we have limit as h approaches 0 of the function. This is my function 3x minus 1, and each time I have x, I'm plugging in my a plus h, a being 2. So I plug in 2 plus h. Then there is a minus in the formula, so I have minus, and then the original f of a. So this is the function f when x turns into a, which is 2. So if x turns into 2, then I have 3 times 2 minus 1. Well, that's 6 minus 1, which is called 5. So minus 5, which is f of a, divided by h. Now we simplify and see what happens. So here we have 3 times 2, that's 6. 3 times h is 3h, minus 1 minus 5 divided by h, and here is limit as h goes to 0. Well, 6 minus 1 minus 5, this minus 1 minus 5, that's minus 6. Minus 6 plus 6 cancels off, leaving us with limit as h goes to 0 of 3h over h. If we cancel the h's, we have limit as h goes to 0 of just 3. Well, there is no h's, so nothing will turn to 0, which means the answer is just 3. And so the slope of our function 3x minus 1 when x is 2 happens to be 3. Now that should be no surprise to us because the function that we looked at is straight line. And so to visualize, here is the graph. The y-intercept is negative 1, and then from that point we have a slope of 3 over 1, which means go 3 units up, 1, 2, 3, and 1 to the right. So here is what our picture actually looks like, and we asked what is the slope if x happens to be 2. So here is 2. What is the slope of our line? Well, the slope for this line is always the same. It's always 2, is always 3, because the slope is in the form mx plus b, and for us the m is equal to 3. So for our example, the slope is always going to be 3, and that's what our definition told us. And visually, that is true because it's not a curve. it's always straight, it's always the same. No matter which x we choose, the slope is always 3. And so this is what our definition told us. The derivative, remember, the derivative is the slope at a point. So what is the slope at 2? The slope is 3. And that's what this tells us. And that's it for this video. If you have any questions on anything, please let me know. Thanks for your time. Take care.